your HMI, okay, your SCADA, okay. So all kind of these kind of facilities are provided in a TIA portal. Okay, so it is not just a very simple software. Rather, we can say that it is a platform that is the integration of various kind of uh, facilities. Okay, so TIA stands for Totally Integrated Automation. It comes with a powerful instruction set and simulation tools. Okay, it increases the productivity of your plant definitely, because we can diagnose a process, we can control a particular process through TIA portal only. We can add HMIs associated to it, we can add the SCADA, we can centrally manage a particular kind of process. Okay, so in TIA, we will go through, we will have a hands-on competency on this also. In TIA, we have two kinds of view. Okay, so first kind is your portal view, and it is very important for you to understand that what kind of view you can have. Okay, so in portal view user, okay, you will do the initial commissioning. Okay, so for example, when you start a particular project, okay, so you will start try to create a particular project. Uh, obtain the string. Yeah. Class, kindly try to be on time because the session is stopped because I have to admit each and everyone. Okay, so it hinders the process. Kindly try to come on time a little bit. If there is an issue, then we can take it, but not for all this. Okay, so for example, when you start to create a program, okay, so what you will do, you will provide a particular path, okay, and you will add a particular controller, that what kind of controller you are going to add. Okay, then you will try to link that controller with your portal, okay, with proper addressing. Okay, so that kind of all things can be done through your portal view. Okay, whereas in your project view, you will get the working area. Now when you have integrated your you can say PLC or controller with your TIA portal, okay, you have managed to have a communication with your PLC, and you have defined what kind of PLC it is, what kind of input and output we have with PLC. Okay, all those is associations or interfacings have been completed in our portal view. Then we can go into our project view. Okay, so in project view, user will get the working area, hardware, catalogs, all instruction sets, logical blocks. Okay, so where you can have all the programming structures, all the input and IO links, all the hardwares that are associated, you can connect to a different hardwares associated to it. Okay, logical block you can add, functional block you can add, okay, data block you can add all these stuffs. Okay, now this is your layout for portal view. Okay, this is something that your portal view looks like. You can switch to your project view through here. Okay, what you have here is that you can create a new project. Okay, you can migrate a project from a particular path, you can open some existing project from here. Okay, now you have your device and network. So what kind of device you are going to have, what kind of PLC itself has various kinds of PLC. Okay, so there is S7 1200, S7 1500. Even in 1200 you have 1214 series, 1212 series, 1210 series. Okay, and also we have talked about DC. Okay, so just to be in the common line, can you answer me that if my PLC has configuration of AC, DC, what does that mean? So can you tell me that power supply is of which kind? Which kind of power supply is given to the AC, DC type of PLC? Others we can't say input. We can say it power supply because input is something different. Yeah, yeah. Okay, Adarsh. So you can't say. And what will be the kind of input provided to the PLC? DC. Yeah, yeah. And what will be the kind of output? Again, it will be DC. Okay. Now let me just say that it is AC, DC, relay. Okay. So just write the answer in that form that your AC will be this, DC will be this, and relay will be this. Kindly write this on chat box. If it is AC DC relay, what kind of configuration it would be? Yes, Ritik, you are correct. Only Ritik has answered. I need few more answers also. Sachin, again, AC is not input, it is power supply. AC supply, DC input, output relay. Yes. Yeah. AC is the power supply, input is your DC, and output is your relay. Okay? Yeah. Yeah. So I think we are on the common. Okay. We all are aligned now. We all are on the common page now. I think. Yeah. Then you have your hardware and network configuration, your block editor. Okay, you can parameterize a particular drive when you are adding a particular drive or motor drive to it. You can parameterize it. Your visualization, which is considered concerned with your HMI or human machine interface configuration. Okay, all these details you are going to get in your PLC session that will be taken by Mr. Suraj. But this is just for the overview so that you can be on a comfortable zone while going through these. Okay, then you can see if you can open the existing program and there is a path specified to it. You can also migrate if you know the path and it is not here. You can also migrate the process and you can just start a particular process. Okay, and you can also change the project view and you can select any kind of your project through here. Okay, this will be your working area. Okay, so now when you have started your project, your this is your project view. That means that at this position of time your view is kind of project view or portal view. Can you answer me that this is your project view or portal view? We I get one answer at the starting and all of you just repeat that answer. Then very correct. Very good. Yes, Ankush, correct. It is portal. Sahil, Muskan, Aprajita, it is portal. Yeah, yeah. It is portal view. You can see that this is your portal view. You have seen here the caption of project view from where you can switch to project view. Okay, but this is a portal view only, right? Why it is portal view? Because we are just selecting the particular project. Okay, we are not gone into your work area till now. Okay, so this is a portal view, not a project view. Let me just repeat it for you. This is your portal view, not project view. Okay, because you will have all these S's in your portal view. Okay, your first screen is going to be your portal view, where you can select a project, select your PLC programming. Okay, you can select your devices and configuration accordingly. We will go into a very brief detail, or we can say we can go into very much details of this particular thing when we you all will be there will be availability of TIA portal to all of you. Okay, so now just you need to understand that this is your portal view. Okay, we are going to go deep into this technology. There is nothing to worry about. So this is your portal view. After that, okay, you switch to your project view. Now you have your working area here. Okay, you can have your assigned PLCs associated to it. Okay, you can have your PLC tags. You can have your organizational block where you are going to have your ladder logic embedded. Okay, and there is a workflow or process flow to continue with it. Okay, I will tell you once all of you have availability of TIA portal. Okay, I will teach you that. Okay, one by one we will do it by our own hands, and we will have that competencies. We have a lot of time and dedicated to PLC only. Okay, so don't need not to worry about. Just you need to understand that at this point of time, this is your portal view where you had a portal. Okay, this is your project where you can handle your project once you have selected it. Okay, you will have your working area where you have specified your hardware. Okay, what kind of hardware it is. Okay, now you can see that it is 1214, 1211. Okay, 1212, and you can see that it is AC DC relay. Okay, this is DC DC DC. Okay, so you can specify, and after this you have your MLFB number. Okay, okay, this is just a you can say a number associated to your you can say product ID. Okay, so in Siemens you have various kind of products. Okay, with various kind of changes. Okay, so for that product specification you have, apart from your type of your PLC, you will also have a product ID associated to it, and it is called your MLFB number. Okay, do you have any doubt till now? Any doubt till now, class? No. No. Okay. I have a doubt. I have said that I have a MLFB number. No one has asked me that what is the full form of an MLFB number. Okay, so there is an exercise for you all. Why I am doing this exercise? Because I want you to remember that what is LMFP number. Okay, it is a German word associated, since Siemens is a German country. Sorry, Siemens is a German company. Sorry. Okay, this name is German. You just search it on Google and answer this on chat box that what is the answer, so that you can remember it for a long time that it is a German name. Yeah, yeah. Maschinen Lesbare Fabricate Bezincha on machine readable product designation. Okay, so why I have done this exercise, why I have used this particular exercise to all of you, to in just, even if you know that what is MLFB number, see, you can just imagine the kind of impression that you are going to throw on the technical person who has come for your interviews. Okay, so it is associated your MLFB number. You have your working area, you have your project navigation tree. As usual in each and every software, you have a working area, you have project navigation tree, you have a task card. Okay, a very common type of structure that is available for many kinds of softwares. Okay, then you have inspector window where you can inspect, or you can say you can check whether what are the properties, what are the messages coming out of diagnostics, what is your information of output, and all that can be shown from your uh, inspector menu. Okay, and you can also have details view. Okay, so what kind of view you, for example, a particular tag, or you can say particular data block, all this information can be provided into your details view. Okay, just kind of a help window which can assess you with all the tools. Then you have menus and toolbar. Just like a software, you have a project navigator. You can have, again, this is the project view. You can always convert, or you can switch to portal view from here. You have your task card, you have your work area. So this is your PLC. Okay, so why we have a working area? Because software does not know that what kind of PLC you are going to communicate with. Okay, so first you need to load that particular PLC. You need to load what are the protocols, what type of PLC is there, and what kind of product your PLC is. So all those properties will be embedded into the software, and you have to load from here. Okay, you can load it, compile it, and load it from here. Okay, once you load this particular program, okay, you can have available user interface languages such as German, English, French, Spanish, Italian, Russian, Korean, and Japanese. Okay, you can also change that. Then you come to your block program. So you can see that these are your default tag table, which consists of your tags. Okay, these are your basic instruction. You can drag and drop, or you can call it just double click it and it will be called. Okay, you have your display here also, where you can have very basic components associated. Okay, you can insert a particular network, and while you are doing all these things, it will be saved in your program blocks. You can manage your program blocks accordingly. Okay, you can see you can have NO contact, you can have NC contact, a not contact, an output. Okay, a not output, a reset, a set, a reset before, a reset set before, SR flip flop, RS flip flop, etc. Okay, you can have all kind of these associations. We will just go through it. We will go into these details. Okay, then you can have frequently used ladder, or you can say FBD diagrams. Okay, functional block diagram. So the ladder logic which has been frequency used can be converted into a functional block diagram, and we can also use that particular function block. Okay. Like you can close a particular block, you can save a particular project. Okay, you can reject a particular block. Okay, and then you can also compile it. Okay, you can compile it, but it can have some errors because you need to address it also. We will look at the addressing also, so we have to address a particular software also associated to it. Okay. Then we can download a CPU. Once we have compiled it, we can download a particular blocks in the CPU. We can download your main OB also, which is your organization block where all your programs are there. And once it is downloaded, okay, so what is to be downloaded? First, your hardware and software. So all new modified software project data should be downloaded. Kind of hardware that you are using has to be downloaded. Your configuration of your hardware, what kind of configuration it is, we have already taken it that it is CPU 1212, 1214, DC, 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 AC, AC, DC relay, etc. What is the MLFB number? Okay, and also the software that what we have created a program. Okay, what kind of program that we have created. If the changes to the objects to be downloaded were not compiled before loading, then compilation is automatically carried before the download. Okay, so if you have not compiled it, so compiling can be done automatically also. Okay, but it is always recommended to first compile it and not download directly. Why it is recommended to compile it first and then we can download it? Can anyone tell me why it is recommended? Yeah, to know the initial errors. Very correct, Nayan. Any other answer? Yeah, Nayan, you are correct. I need answers and response from your side also. Class, to know compilation errors or initial errors. Yes, Rajnandini, very correct. Only two answers. I again repeat that answer can be of any kind, but I need some answers from your side. Yeah, program is working to know output is right or not. We are not getting any output at this particular stage. We can't say that output is right. Yes. See, if there is an error during compilation, it will continue to download it. Okay. And once there is an error downloaded to it, then the system might hang. Okay. Because of an initial bug. Yeah. Yeah, Rajan. It might hang. Yeah. So if there is a bug at the initial stage and it has not been sorted out at the compilation stage, then it might hang, or we can have different issues regarding to that also, right? We know that if a bug is not being addressed at compilation level, then during download it can create a mess around a particular software. Okay, so therefore it is always recommended that you first compile always and then you can download it. Okay, so and download is only carried out if compilation is error free. Okay, so during download only it is going to provide you a particular error. Okay, now these are your monitoring block. This is how your monitor will look. So now see, in this case you can see that this is not active and this is also not active. Oh, sorry, this is active and this is active. So you can see that current is passed, okay, through this block also, and through this contact. This is your NO contact, this is your NC contact. Okay, and this is your output. Okay, here neither your NO contact is activated, neither your NC contact is activated. So there is no current pass. Okay, so we can also monitor. You can see their glasses kind of icon. From this glasses kind of icon, which is your monitor block, you can on or off your you can say monitor condition also. Okay, so if a status is fulfilled, then it is complete represented by green color. And if it is not fulfilled, then it is represented by dotted blue color. So now you can see that we can upload from a particular device, we can upload a particular program, or you can say any block from a particular device. As we have a download facility, we also have a upload facility. You will get these details more and more when you will have TIA portal in your hand, and it might look a little bit confusing, or you can say my little bit tough at this point of stage. But when you will work on a particular problem associated to it 2 to 3 times by your own, then you are going to get compatible with this. Okay. But we have to start from any stage, so we are just getting it started. Okay, so things have just started when as far as PLC is concerned. Okay, you will get a very good hands-on competency on this. Okay, so by using the upload from device button, individual block or the entire program folder, okay, can be uploaded into the project. So for example, you already have a program, you made a program, we need to upload that particular program also. Okay, so these are the symbols. Folder contains objects whose online and offline versions differ. So it can be that your version was, you have made a program on version 15.1 and you are using it on version 15. Okay, so because of this, it can happen. You can get this particular output. When this is and this icon is shown, then result of comparison is unknown. Okay, so when you compare a particular output block, if it has a output of which cannot be addressed by a processor, then this kind of result can be achieved. Okay, so what kind of result will be unknown to your PLC? Can you say some answers? Any type of fluke? What kind of result comparison will be unknown? Any answer will work. No, just a fluke. What kind of output uh, your processor cannot address? So, okay, let me remove my question. I'm just giving a output which is 1 divided by 0. Can that be addressed by my processor or my PLC? No. Okay. Okay. If I have a ladder logic, okay, if I have a ladder logic which has no logic in between, okay, which has no logic in between, and I am directly supplying this a single line rung to the program, will that be addressed by? So just let me give you an example like this. Hmm, let me duplicate the slide. Let me just delete this. Yeah, you have a ladder logic like this. You have made this particular ladder logic. Okay, you have not provided anything between this. Okay, will this be addressed? Will this be addressed? No, it will not be addressed. uh, it just a minute class. हाँ बोलिए. क्या चीज? हाँ टाइल्स टूटे हैं. Class, just give me 2 minutes, just 2 minutes. Yeah, now let me just take another case, a very simple case in front of you. You have a logic. Okay, this is your NO contact, normally open contact, and it has an address of I0.0. And this is the address of your output, which is your Q0.0. And this is your NC contact, which is your I0.0, and this is your Q0.0. Okay, so when I0.0 is at zero stage, okay, at zero stage, then this is the normal condition. And in normal condition, this will be open, and this command should be that it is closed. Okay, again, if I0.0 is 1, the command will go, okay, sorry, if I0.0 is 0 again, not 1, then this will be normal condition. It is normal close, current will pass, and it will state that your Q0.0 is 1. Okay, so can this condition be determined by a PLC? Can this condition be determined by a PLC? Okay, I think you don't know a very basic about ladder logic. Do you know about ladder logic? A very simple basic about what is NO contact, NC contact. Okay, okay. My bad. I should not have started with it. We will take basic of ladder logic. I just thought that you might be knowing about basic of ladder logic. We will cover from zero, but this will be an indeterminate state. This will be an indeterminate state. We will completely learn from scratch about the ladder logic. Don't need not to worry about it. We will completely learn it from scratch. But for now, you can understand that for a single logic, it was giving 0 for Q0.0, and for the same logic, it was giving one position for 0.0. Okay, so at same input we were having two output, so it was not, it was something that cannot be determined by a PLC. Okay, so for these kind of outputs you will get this result of comparison un. Okay, then you can have online and offline versions of objects are identical. That means that both are downloaded. Okay, this can be done that online and offline version of the objects are different. That means that you have made a program. Okay, you have made a program, you have downloaded it on the PLC, and then you have operated it. Again, you have changed the program, but you have not downloaded it on the PLC or uploaded on the your hardware. Then what will happen? Your hardware will have different program, your portal or your project view will have different program. So your online and offline versions will have different objects. So this can happen. This object only exists offline, so you have not downloaded and compiled that particular software on the hardware. Okay, so it will only exist in offline mode. Okay, now what happens? You change or you deleted the program after downloading, then you can have this kind of icon. Okay, just get a brief view about these particular icons. You have to deal with these icons much more when you are going to work on TIA port. Then this is your Profinet. Okay, so this is your IEC 617842, and IEC 61158. Okay, kindly note these IEC, you can say, standards separately in your notebooks, because these standards will be asked during your exams. Okay, so when we will have a dedicated test associated to this particular session, I'm going to focus on these standards also. Okay, so note them separately on your notebook. Okay, and kindly bold them, because these standards are important for you to understand also. What kind of standard does Profinet works? So Profinet stand for Process Field Network. It fall under IEC 617842 and 61158 of Industrial Communication Network Field Bus specification of real-time Ethernet. Okay, similar kind of industrial Ethernet. Okay, so the connector type is RJ45. Okay, your response time is 1 millisecond. Standard length can be 100 meter. Okay, your maximum node connection can be 256, and your communication speed can be 100 megabytes per second. Okay, megabits, sorry, not bytes. Okay, then you have PLC simulator also. You can simulate a particular program without integrating it with a PLC. Okay, so in automation lab, where you can have dedicated PLC which can be communicated to your TIA portal, but in mechatronics lab you are going to see PLCs that are blocked for communication, because they have specified ladder logic programs which are very much large in size, and we cannot change them, because a minor change can alter the process. So that is why they are blocked. But we will learn the logic, ladder logic behind all the processes separately, and we are going to work on in automation lab for these ladder logics. Okay, so we can understand a particular ladder logic for a particular process here in mechatronics lab. We can understand the whole flow process here. We can understand how PLC works. We can simulate that particular process, any kind of process, through PLC simulator without communicating a PLC to it. Okay, for example, you want to check a particular program that whether it can work, yes or no. Okay, so what will you do? You can't directly check it through PLC. If you don't want to check it through PLC, you can use a PLC simulator. Okay, so is used to work offline. If user want to work on software without using PLC hardware, then your simulator is required. Okay, so now what are the kind of PLC blocks? Okay, so there are three kind of PLC block. One is your organization block, where you will have your program downloaded. Then you will have your function FC. You will have your function block, which is again dedicated. This function is dedicated to your specific function, and combinations of functions or combinations of logic contains a function, and combination of functions will contain a functional block that can be separately saved. Now why we require this kind of, why we are not making a single ladder logic for this, is because for a very simple logic this can be very complex. So what we can do is that we can create a function block for a combination of ladder logic, and we can create a function out of it. With the combination of function we can have functional block also, and we can have various type of data also, and we can save that particular data. For example, what kind of data we can have? We can have input data, output data, and we can have memory data also. So that kind of data can be saved in data block. This particular organization block will consist of all these things. Okay, your FC will be a specific function for a specific function that we can call. Okay, we can call that particular FC, FB, and DB into your organization block. Okay, don't be confused by these things. You are definitely going to work on these things when you are going to work, when you are going to come into the center. You are going to work on these also. Okay, so need not to worry about it. If you are not getting it, just you can understand this point, that FC, FB, DB are containing your specific kind of functions and memories, and these can be called by your organization block for operation anytime. Okay. Okay, this is important for you to understand. So you can see OB stand for organization block. OB form the interface between operating system and user program. Okay, so it will be an interfacing between the operating system, which is your TIA portal, and you can see user program. Sorry, operating system will be a PLC and user program will be a TIA portal. The entire program can be stored in OB1. So that entire program will be saved in your OB1, or you can say your organizational block, and it's called the cyclic block system program or the program. The programming done in OB is called linear programming. Okay, so it will be linear in nature. There are many different OBs executing as different conditions and its priority. So it will be linear in nature. Okay, we can't have we have a rung type of system that it performs in a particular cycle, and that will be linear in nature. FC stands for function. Okay, it is used to define a function which can be executed on command from an organization block. Okay, so it will be a specified function which can be called by an organizational block. Okay, and FCs can be thought to be as subroutines. Okay, so it can be a subroutine which a programmer can call. Okay, so if you understand a very basic of programming, even if you don't know the basic of programming, just understand this thing, that we have a particular system in programming that we call as canning. We can a particular kind of logic or program into a particular system that we call a subroutine, and we can always call that subroutine in the main program. Okay, so what is the benefit of this you can say process? So what is the benefit of using these subroutines? Any answer can work. I just need your answers so that what can be the benefit of this subroutine? What benefit can we get through this exercise of using subroutine? Any kind of answer will work, whether it is right or wrong. Kindly answer this on chat box. Okay, let me just repeat it. I'm just repeating it again and again, that FC is a kind of your subroutine, which is a specified program which can be called by our organizational block. We could have made that program in organization block separately, but we have preferred to make it on FC and call it to organization block. Why this exercise is important and what benefit we can get from this particular exercise? I will repeat this question. Yeah. Can be called for fast process. Yes, very good Adarsh. Very good Sahil. Yeah, we save our time also. Yes. So that we can use it again and again. Yeah. Reuse of code. Okay. Yes, very correct, Bhanu. Yeah. Yeah. So fundamentals are kind of same, whether you are using ladder logic or C++ or Python or Fortran. Okay, the fundamentals are going to be same. You need to call subroutines. You need to make subroutines. The toughest part will always be a making of a particular subroutine. Okay, and to integrate in a higher process. Okay, so did you get it, class? Kindly respond yes or no. Till now, did you get it, or you have any doubt, class? Please respond. I need response from all of you. Yeah, yeah, yeah. So it is important for you to understand these structures also, right? You, because the definition is also very important. What happens is that you just go into a flow of learning. You just go step by step that what is how it can you can make a particular program. You know it, but when the system get more and more complex, you need to add various kind of these blocks or data blocks, every kind of thing to it, and then it becomes complex because you don't know what is the meaning of each and every component. So this is also important. Okay, now FB stands for functional block. Basically, function block offers same possibilities as functions. In addition, function block have their own memory area. Okay, so these FC are not going to be having their own memory area, but your functional block will have their own memory area in the form of instance data blocks. Okay, so as a result, function block are suited for programming frequently recurring complex functionality such as closed loop control tasks. Okay, what does that mean? If we have a linear type of programming where your function has to be utilized only for once, you can call your function through OB. Okay, but when you have a cyclic program, for example, you have a timer. Okay, you have a particular kind of timer where you want that it should be in cyclic in process. For example, you have an indicator. Your indicator starts, stops, and it works in a particular cycle. Okay, so you don't want to have a linear programming for that. You want a particular kind of cyclic programming associated to it. So what you will do, you will just add a memory area to a particular function, and you will consider it as a function block, and you will associate it into your organization block. Okay, so it can be frequently recurring and complex functionalities such as closed loop control tasks can be operated through your functional block. Okay. Then DB stands for your data block. Data block is just like memory, which programmer can use during the program execution, because inbuilt memory, or you can say memory flags, are limited to the PLC ranges. Okay, so if there are much more data that is required to be saved, for example, you have memory bit areas M0.0, M0.1, M0.2, but these are for your single logic control. Okay, but if you have a data which is varying, okay, so for example, you need to capture the temperature, say. So temperature can range from it is a integer kind of thing, or you can say it is a float type of character, so it needs a huge memory to save. So what you will do, you will start with a data block with a particular timer or counter, and you will associate a data block to it. Okay, now let us just look at TIA bit instructions. We will go into these details, and these will be covered by much more deeper by Mr. Suraj sir. This is just an overview so that you can have compatibility. Okay. Now we will start with TIA bit instructions. Okay. So what is NO contact? What is NC contact? Similar examples of ladder logic and FVD we are going to cover. Okay. So what is a NO contact? Let us just first look at this. So this is the representation of your NO contact. Okay, and you can see that tag 1 I0.0 is associated to it. Okay. Class, just a minute. राजेश जी, किसी के बाद PCM पढ़ी होगी? PCM, हाँ, PCM दवाई, शरीर दर्द वाली, शरीर दर्द वाली जो दवाई होती है ना, PCM, पैरासीटामोल. अच्छा, पैरासीटामोल पूछता हूँ सर. किसी के पास पढ़ी हो, ग्रुप में डाल दो ना. अच्छा, हमें ग्रुप पर डाल दूंगा. ठीक है, ठीक है, नहीं मैं डाल दूंगा. ठीक है. Yeah, class, sorry for interruption. Let us continue. Oh, I am not unmuted. Yeah. Am I audible? Is my voice clear to all of you? Class, kindly respond on the chat box. Yeah. Yeah. Okay. Okay. Yeah. So now you can see that this is your NO contact. Okay. What is the meaning of NO contact? So your NO contact will be active with the NO contact. That means that this is a normally open contact. Let us just see an example of normally open switch. So this is your kind of your normally open switch. Okay, what will happen in this, that this switch is open and current cannot flow through this junction in normal condition. Okay, that means that when force on this is 0, the output is 0. When force on this particular switch is 0, then your output is 0. And here your force is your input. Okay, so if your state of input is 0, so for example, your I0.0 is a sensor. Okay, let us say it is a PNP sensor. Okay, and let us say that it is a proximity kind of sensor. Okay, a diffusion kind of sensor. Okay, so when a material is coming in the vicinity of this, okay, the rays will fall back and you will get a signal. Okay, so when a material is in front of this, the state will be 1. And when there is no material in front of this, no rays will come back and the state will be 0. Okay, so now this state is your I0.0, which is your input stage. Okay, so for a condition when there is no material associated to your sensor, we have looked at the diffusion sensor. When there is no material, the rays will not fall back through diffusion. Okay, and the stage will be 0. And when the material is present, the rays will fall back to the sensor and a current will be flown and the stage will be 1. Okay, so what will happen here? For example, if a material is there, I want an LED light to work. Say this is an example of your LED light. I want that when a material is here, then this LED light should brighten up. Okay, so I will make a ladder logic like this. I will give this LED light an address of Q0.0. I will connect this to my PLC. Say this is your PLC. This is your PLC. Kindly focus on this. Okay. I will connect this wire in the input module of my PLC. I will provide the output through a particular relay or something else or directly to my LED. Now what I want that when material is present, this LED should brighten up. Then what I have done is that I have used an NO contact. Okay, which is your normally open contact. Okay, what does that mean? When the input is 0, and I have addressed this as Q0.0, I have addressed this as Q0.0. Okay, and this is your NO contact. NO contact means just like your NO switch, when 0 is given, then there is no flow of current. Okay, what does that mean? That when there is no material present here, you will get an 0. So I0.0 will be, say, let us say this is I0.0, this is Q0.0. Q0.0. Okay, so now for this particular sensor, when there is no material present, for diffusion type sensor, no current will be passed. I0.0 state will be 0. Since it is 0, and the logic that I have given, this is our logic, this is our ladder logic, no current is going to flow from this position. Since there is no current passing through this, your Q0.0 will be 0. Your Q0.0 will be 0. Let me just repeat it again. For a particular system, suppose that there is a diffusion type sensor. We know diffusion type of sensor. that whenever there is a material in the vicinity of diffusion type sensor, the rays will diffuse back to the sensor and we'll get an output. So our address of I0.0, our address of I0.0 will be fed as 1 when there is a material in between. But when there is no material in between, then the address of I0.0 will be 0 and no flow will pass through I0.0. Therefore, the condition of Q0.0, since this circuit is not completed, will be 0. Okay, now when a material is there, the input condition will be 1, and for an NO contact, for an NO contact, normally open condition or normally open contact, 1 is not the normal stage, 1 is the active stage. This will be closed contact. Okay, now this contact is going to be closed just like this. When there is a force, this will be closed. A flow is going to pass through this. It is going to allow the current to pass through it, and your Q0.0 will be 1. Is there any doubt till now, class? Shall I repeat this? I can repeat this if you want. Should I repeat this, class? Kindly respond. No. You understood this. Yes. Okay. 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 If you understood this, I have a question for you all. Okay. Let me just duplicate this particular slide. Delete this. Now, instead of diffusion type of sensor, the kind of sensor that I have is through beam type of sensor. Through beam type of sensor. Okay. I have connected. Now see, this will always be provided with a particular supply. This will be a 3-wire. This is your emitter and this is a receiver. Okay. Now the issue is that in diffusion type sensor, when there was material, okay, when there was material, in active stage current was passing through it, and in a normal stage current was not passing through it. So it was a kind of your NO switch, or you can say NO input. But in this kind of input, you can see that when there is no material, then these rays are falling on your, this is your emitter, this is your receiver, falling on your receiver, and because of this current is passing. But in the second case, you can see that when there is no material here, okay, when there is no material here, your current is not flowing. Okay, so if you are going to connect your input to PLC, my question to you is, and you have connected your PLC to an LED. Say this is your example of your LED. Okay, and your ladder logic is same. You have an NO contact. Your input address is say I0.0. Your output address is Q0.0. Okay, now please listen. Okay, when there is no object, your current will flow. When there is an object in between, current is not going to flow. Okay, now just tell me, with this kind of solution, when there is no object in between, okay, then your LED will brighten up, yes or no. Let me keep this. Okay, my question to you is, when there is no object, yes, it will be brighten up. Why? Because this is your NO type of contact. Okay, okay, and when there is a material in between, no light is going to pass. This is not going to get activated. This will remain as an open switch. Current will not flow, and your LED will not lighten up. Okay, so for that case, you need an NC contact. Okay, for that particular case, you are going to have an NC contact. So now you can have a combination of your NO contacts also. Okay, so your combination of NO contact, now you can see that you can just associate a particular, just let me use this eraser. Okay, I can't erase this now, my bad. Yeah, so now you can just have a look here. Say you have an outcome here, Q0.0. Okay, and this is your output for say Q0.1. Now when this condition is 0, no current is going to flow through this. Okay, there will be no current flowing through this. Again, if there is no current flowing through this, there is no use of any activation to this. In any case, your Q0 will be false. Okay, and if both are in 0 condition, then no current is going to flow in Q0.0. Your condition will be false for this particular case. If any one of this is 0, the current is not going to flow in series. Your Q0.0 is not going to get activated and it will be false. Okay, it will be true or 1 in only one condition, when your both I0.0 and I0.1 are true. Okay, so this is an example of, so this particular is an example of which kind of gate, you know which kind of output is this, and okay. So rather making a pneumatic solution or uh, pneumatic and or gate, integrating a physical system into a process, or by controlling it but through relays, creating a AND logic through relays, we can directly use it in a simple program. We can, now it can look very easy to you that it is just a 2-step program, but you can understand the weightage, that how much amount of you can say ease of process it has done to your industries. Okay, so this single program had reduced all the AND and OR gate operations that are used in pneumatics. Okay, a very simple AND and OR gate can directly be converted through a very simple ladder logic. Okay, you always will have to work with these logics only. The combination of these logics are going to work in every kind of technology. It is just for you to understand with each kind of technology how you are going to make a particular logic. Similarly, you can see that if this is 0, this is 0, your output is going to be 0. Okay, but if any one of them is 1, your output is going to be true. Okay, So again, this is an example of this particular is an example of OR gate. Okay. Yes, OR gate. Now see how simple things are. Ladder logic is not something very much difficult. Okay. So rather than making two symbols for this and to make uh, two singles for this, we can have a direct function block diagram. We can call this particular diagram as AND gate. Okay. And you can see that your NO contact can be like this also. Okay. So you can have your NO contact like this, where you can see that this is normally open. Okay. Now you can see with our AND gate and OR gate, you can see this. Okay. This was the representation of your simple NO contact. This is a representation of your simple NO contact. But for AND and OR gate, we can have specialized function block diagrams also, which are like this. Okay. So now you can see this I0.0, I0.1. You can address it in a single function block diagram, and you can get output accordingly. AND will be same functions of and OR will have same functions of OR gate. Okay. Rather than making two icons, or you can say NO contacts, you can have your function block diagram. Okay. Now we can move to NC contact. Okay. Now let us just have a focus on this. Okay. So we had a situation earlier that for your through beam, or you can say for your diffusion type of sensor, your problem was solved. That whenever there was a material, your LED was getting on. Okay. But if there is an NC kind of contact and you want the same kind of solution, then what you will do? You can have your NC contact. Okay. So you can also integrate your NC contact. So this is a NC contact. Okay. What NC contact will do? Let us see this. So when the situation, NC means normally closed. Okay. And you can physically represent it as this kind of switch. Let us just, my bad. I'm very bad at drawing. Sorry for that. Yeah. Yeah. This kind of contact. This is a NC kind of contact. Okay. So whenever there is no force attached to it, this will be a normally closed contact. That means that whenever zero stage is there, so for your address I0.0, okay, whenever there is a zero stage, the current is going to flow. And when your I0.0 is in one stage, okay, is in one stage, then there will be no contact. So there will be no flow. Okay, so your Q0.0, will be 1 at this point of time. Your Q0.0 will be 1 at this point of time, and your Q0.0 will be 0. at this point of time. Understood? Is there any doubt till now, class? Is there any doubt? Kindly respond. Yeah. Okay. Okay. I think things are pretty simple till now. Yeah. So if there is no doubt, if there is no doubt, let me just draw me the truth table for this now. If you don't have any doubt, yeah. So draw me the truth table and answer me on WhatsApp in the group the truth table for this kind of contact, and tell me that what kind of logic this is, and say this is I0.0, I0.0, this is I0.1, this is Q0.0. Draw the truth table along with the logic for this and this kind of arrangement. Pardon me for my drawing. I'm not very much good at this point of time in drawing like this. Okay. So you have these two arrangements. Kindly respond it on WhatsApp group. What kind of output is? You can address it like I0.0, I0.1, Q0.0. Okay. So Sachin, yes, if it is zero, it is zero, it is true. If it is one, it is zero, false, false. If both are one, false. So what kind of gate it is? Kindly also mention that. Nayan, you have mentioned it. Okay, yes, correct. NOR and NAND gate. Yeah, correct. I think Sachin has mentioned. Yeah, correct, Sachin. Kindly also mention the names. Sahil, NOR gate and NAND gate. Yes, correct. NAND gate and NOR gate, very correct. NOR and NAND, yes, correct. अब है NOR gate, yes, correct. NOR, NAND, Abhay is correct, Muskan is correct, and Abhay is correct, Varun is correct, Alok is correct, Ankush is correct, Bhanu is correct. Kalpana is correct. Yes, NOR and NAND gate. So this is a NOR gate. This is a NAND gate. Yes. So I think most of you are aligned. True, false, false. Yes, it is NOR gate, NAND gate. Yeah. I think most of you are aligned, and most of you understood this. So this will be your output. Most of you have done this correctly. So now we have seen NO gate and what we say your NO contact and your NC contact in FBD also. Okay, so what is the difference between this NC contact FBD of your NOR, or you can say NAND gate, okay, and this block? Okay, so in the physical representation of say this block, let us just take an example of this NO contact and this NC contact. What is the difference? What kind of difference you are seeing in both these? This and this one. Yeah, small circle, or you can say small bubble at input. Very nice observation by Sahil. Good. So you can see that there is no bubble here. This is just activation. What kind of activation you might have provided? Don't get confused by this bubble. Just focus on this part. There, here it is a straight line. Here it is a straight line. But in NC contact, you will have a bubble. This bubble. Let me use a laser pointer. This one. Okay. Or use a pen and this one. Okay. This one. So this is the difference between your NC contact and NO contact. It is having a straight line, and here you have a bubble. So you can represent it accordingly. And again, this is your bubble, and you can just have your NOR gate and NAND gate. Okay. Just focus on this. That your first example was this one. Okay. And here your second example. This is your bubble. Okay. This is your output coil that we have already covered, that this will be your representation of your output coil, and with FBD symbol there will be a equal to sign. Okay, now you can see the output. Okay, example in that particular ladder logic, if your I0.0, a sensor with I0.0 is in 0 state, this is in your 0 state, then your output will be false. Okay, if any one of this is in the 0 state, your output is going to be in the false. But both are 1, then it is going to be true. Okay, if both are 1, then your answer is going to be true. Now this is your example for your XOR gate. Okay, now just let us have a very detailed analysis of this particular problem. Okay, so if I0 is 0, your I0 is 0, your current is not going to flow from this. Okay, your current is going to get flown from this direction. Okay, if I0.1 is 0, then your current will not flow from this direction, but the current is going to flow from this particular direction. But overall output will be 0 because current is not flowing in this particular direction, so this is false. Okay, now yeah, just let me do it a little bit quick. Red pen. Now if I0.0 is 0, I0.0 is 0, the current is not going to flow from this particular direction. Okay, and current is going to flow from this particular direction. Okay, if your I0.1 is 1, your current is not going to flow from this particular direction, but it is going to flow from this particular direction. You have a flow of current from this path, and your current is going to flow through Q0.0, and your position is going to be true. Okay, I think there is no doubt in this. I hope there is no doubt in this. And now just let us very quickly look into this also. Let me use a red pen. Q0.0 is 1. If Q0.0, sorry, I0.0 is 1, the current can flow from this particular direction. Okay, the current will not flow from this particular direction. Okay, if I0.0 is 1, yeah. Okay, and if I0.1 is 0, then it is going to allow the flow of current in this particular direction, and it is not going to allow in this particular direction. You have a flow, your condition is true. Okay, again excuse me, yeah. Now in this particular condition, if I0.0 is 1, so it will be allowed in this particular direction, it will not be allowed in this particular direction. And for this particular contact, I0.1 is 1. Okay, so this particular contact will allow the flow, this particular contact will not allow the flow. Okay, so there will be no flow, so this condition is false. Okay, so this is a representation of your XOR gate. Understood, class? Is there any doubt till now? I've lowered my pace to the level that I could have. Yeah, so it is very simple. You can see these logics are very, very simple. Okay, it is just the implementation of them that makes it tough. Okay, now let us just have a look at the wiring, PLC wiring diagram. How a schematic diagram can be converted through its wiring, and how we can add ladder logic to it. Okay, or we shall we have a break? Shall we have a break, or shall we continue? Okay, okay. We can have a break of say 15 minutes. We'll meet at 4:25. Okay, kindly be available at 4:25.